Okay, on the first one, when it's asking us to use a table, it says find the whole number solutions. So what are whole numbers? Or what are not whole numbers? Decimals, fractions. What other thing is not included in whole numbers? Negatives. So is 0 a whole number or not a whole number? It is a whole number. It is what separates whole numbers from natural numbers. Whole numbers include 0. Natural numbers are your counters. So whole numbers start at 0 and go on up to, not technically infinity, because infinity is not a whole number, but there's always one bigger than the last number you thought of. And so we are going to find the whole number solutions for these problems. And what we're going to do is we're going to do a table. You're going to create a column of x's and a column of y's. And we are going to work through problem 2 and 4 on these exercises. So let's start off with 2. We're going to take the first rule, and it tells us x minus y is greater than 1. Greater than or equal to 1. So that means this number has to be 1 more than your y. So what number can I start x with if it needs to be 1 more than y? Remember, 0 is a possibility. 1. So we're going to go 1, 2, 3, 4, 5, 6. Wait a minute, I can keep going forever, right? I need to figure out where to stop. So let's look at my second rule. And let's pretend like y is 0, because that's the smallest y we can have. The second rule is 6x plus 3y is less than 21. And so, if y was 0, that term's gone. What is the biggest number I can replace x with to get less than 21?
6.
6 times 6 is 36.
3.
3. So, I technically don't need anything in my chart below 3.
Below or above?
Below. Because I'm looking for numbers that will be multiplied times 6 and is less than 21. Okay? So I'm using that second rule to help me figure that out. So let's go ahead and let's write out a list of numbers, the whole numbers, that if I subtract y from x will be greater than or equal to 1. So what number can I subtract from x to get us 1? 0. What numbers can I subtract from x when it's 2 that's going to be greater than or equal to 1? And? What numbers can I subtract from x that will give me a difference of 1 or more? 0, 1, 2. So this is the ones that fit this rule. Now we're going to look at the other rule. The other rule said 6 times x plus 3y has to be less than or equal to 21. So we are going to take each of our x's one at a time and figure them out. So when x is equal to 1, I replace the x with 1. So 6 times 1 is 6. And then I'm going to check out these y's. So 6 plus 3 times 0, is that less than or equal to 21? Because that's 6. Is 6 less than or equal to 21? So you can either circle or highlight the ones that work. And so now, let's figure out when x is 2. So that will be 12. 3 times, and we're going to check out these numbers. 3 times 0 is less than or equal to 21. So 12 plus 0 is less than or equal to 21. Is that right? Yeah. Okay. Let's check out whenever it's 1. 12 plus 3, is that less than or equal to 21? Okay, both of those check out. So I'll highlight those two numbers. Do you see how I'm choosing what to highlight? Yes? Okay. Okay, so now let's go to the next one. 6 times 3 plus 3y is less than or equal to 21. Okay, so that's 18 plus 3 times 0. Is that less than or equal to 21?
Yes.
So that one gets highlighted. Now let's replace that 0 with the 1. Is 18 plus 3 times 1. So 18 plus 3. Is that less than or equal to 0?
Yes.
Okay, let's go to the next one. Or less than or equal to 21, excuse me. 3 times 2. So 18 plus 6. Is that less than or equal to 21? No. So this one doesn't work. You don't have to X out the ones that don't work. I like that because it helps me see what I'm doing. Yes, Jesse.
So for the answer, like, if we had like our work on the other page, would we just put like 0 and 1?
You're going to actually list out the ordered pairs. And so our answers would be 1, 0, 2, 0, 2, 1, 3, 0, 3, 1, 3, 2. So there's 6. No, wait a minute. There shouldn't be 6.
2.
Oh,
0.
the 2 is not there. Sorry. I was like, there should only be 5.
And 2, 0. Is not 1, right?
It is.
Oh, it was
X
X was 2.
is 2, Y is 0. So if I need you to write out a list of ordered pairs, that'd be the answer. On this assignment, I believe it just asks you to draw the chart and highlight. No, it does say the whole solution, so you actually have to go back and do order pairs. Any questions on that one? Okay, let's do another one together. We're going to do number 4 together. Number 4 is a little bit different. It says y is less than 3. So that means the biggest y value I can use is 3. So my y's are restricted this time to smaller than 3. So that means I can have an answer of 0, 1, 2, or 3 on the y column. Now x's, it doesn't have a restriction for the first part, so I can keep going. And I'm just going to go to the 6th one right now, and we'll look back at it and see if there's any more that we need to do later. So our x's and our y's. So x was 0, we could be at 0, 1, 2, or 3. When x was 1, we could be at 0, 1, 2, or 3. And so forth. And I could keep going. But like the last one, we have a second rule that helps us figure out where to stop. And our second rule, in this case, is 4 times x plus 2y is less than 12. Okay. So what is the biggest number we can use? If y was 0, where would x stop at?
2. 3. And then it's just
So if we had 3, that'd be 4 times 3. Is that less than 12?
No.
No. So we can't have the 3s, the 4s, the 5s, or the 6s. And so we are going to take 4 times 0, because I want to, again, start with the first row, figure out what my x is, and then do my y's from there. So, which ones are going to work? So, 2 times 0, is that going to work?
Yes.
2 times 0 is 0. That works. So 0 is a solution. 2 times 1. Is that less than 12? Yes or no? Is 2 less than 12?
Yes.
2 times 2. Is that less than 12? 2 times 3. Is that less than 12? Okay. So all of those were possible solutions. Now let's change it to where we're looking at when x was 1. So that's going to be 4 plus 2 times my number that I'm going to go through. So we're now looking at this row. So 2 times the first y, which was 0, is 4 plus 0 less than 12. Okay. How about 4 times, or 4 plus 2 times 1? I know some of you are already finding shortcuts for this. That's fine. I don't care if you use a shortcut on your paper. And so 2 times 2. So 4 plus 4, is that less than 12?
Yes.
4 times 3, or 2 times 3 is 6. 4 plus 6, is that less than 12?
yes.
Now let's look at it again with replacing x with 2. So 4 times 2 is 8, plus now let's go through our y's. 2 times 0. 8 plus 2 times 0 is 8 plus 0. So that's less than 12. Now let's do 1. 8 plus 2, is that less than 12?
Yes.
8 plus 2 times 2. 8 plus 4 is 12. 12 is not less than 12, so that's not going to work. So 2 and 3 don't work. So if I was to write my list of ordered pairs,
0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1. Thank you.
I'm going to write a little bit slower, so if you're writing this down, you can hopefully keep up with my writing, because I'm slow. And on these, you are going to have to show me your work of your table to get full credit.
The X and Y table?
Yeah, the X and Y table like I did here. Now, where I've marked out and it's not used, those lines where it stopped, you don't have to keep going through extra lines. So if you figure out where it stops, you don't have to do the table.
Do
That's
you
just,
know to go to 6 on both of these?
I just was trying till 6. That's when my paper ran out.
Oh, okay.
And if I couldn't, I thought hopefully it would happen before then. And that's the reason I started looking at that second equation to help me figure out where to stop. And so we should have 10 solutions on this case. These are our whole number solutions. As you can see, this is a very tedious way of doing it. It's possible to find your whole number solutions by using tables. What if I asked you to find your rational solutions? Would tables be the best method? No. Graphing is going to be the best method. And so let's look at some of the graphing. We're going to look at question number 7. And if you'll notice that on your graphs, I numbered your graphs. So find graph number 7 on your graph paper that I gave you. I gave you 3 extra graphs in case you make mistakes.
Another graph paper.
No, y'all have it. So I gave you 3 extras. I recommend doing this in pencil because if you do pen with this, there are so many places you can make little mistakes and you can't erase pen. So I recommend pencil for doing these. So let's look at 7. And with these, you're going to take each equation one at a time. And I'm going to use 2 different colors to help us see the 2 different graphs showing up. And so 7 was x is greater than 1 is the first one. And the second one is y is less than x plus 1. And we're just going to graph our inequalities. They are going to be 2 separate lines, just like whenever y'all are graphing at the beginning of this unit, where y'all graph the 2 separate lines. Except for this time, when we have inequalities, there's going to be a shaded region. When you're solving systems of equations, when there's an equal sign, there are 4 methods to solve it. I have given you 3 so far this unit. The 4th one we're going to cover next chapter. With systems of inequalities, when you're looking for all solutions, the only way to do it is with graphing. So there's not another option. You have to graph these. You can find out the whole solutions by using a table, but other than that, you can't use a table for any of these. And so in real world situations where you're looking at objects, where you can't have partial objects and you can't have negative objects, the table works. But if it's not a real world situation of whole number objects, then you have to go to a graph. And so let's look at x is greater than 1. So what I do when I'm graphing is either an x, and there's no 2 variables in this one. It's just either x is greater than or y is greater than or less than. Then I go, okay, when is x equal to 1? Here. Now, it has to go perpendicular to the axis it's on. So it's going to go up and down. There. Oops. And it says x is greater than 1. So if I was to take my graph and I think about it in 2 sections, are the numbers when x is greater than 1 going to be to the right of that borderline or the left?
Right.
To the right, because 2 is greater than 1. Just take any point to the right of it and see if it works. And so I'm going to draw little arrows just coming off my line so I know that I'm going to the right there. You can draw them anywhere on the line. It's just, those are just my notes to self. They're not actually part of it, so if you don't want to do it, you don't have to. This is how I do it to make it easier for me. And so that's all I have to do for that line. Now let's go to the next one. For this one, we have an x and a y. So that means we need to find our slope and y-intercept. Do we have it to where y is by itself? So that means we can identify our slope as what's being multiplied times my x, which is 1. And we want our slope written as a fraction, so we'll use 1 over 1. Just like what we talked about earlier. Positive slope, rise in right or fall in left. So from my y-intercept, I'm either going to go up 1, right 1, or down 1, left 1. And my y-intercept is this number at the end. So it's going to be positive 1. So y-intercept is when it crosses the which axis? And I forgot to say this on the first one. How come did I draw mine dashed on this one?
Because it's not equal to.
The bar isn't underneath it, so there's not an equal to. And so that's the reason I know to draw it dashed. This one's going to be dashed as well. And so you're going to draw up 1 over 1 dashed line. And make sure you go all the way to the edges of your graph paper, because you're basically creating borders. Have you poured something and you wanted to have walls to contain it? That's what we're basically creating with this. We're creating containing walls. The edges of our graph paper are containing walls, and the edges of our lines are containing walls. So if you've ever been to the ocean and try to create a little tidal pool in the sand, that's what you're creating with these lines. So when the water comes in, it can't go past. And, oh, I did it again in this. I'm going to graph this back over with white because white shows up better. So from that line, it says y is less than. So less than, was that above the line or below the line?
Below.
Below. And again, this is for my purposes here. I'm about to put numbers in here. We have our lines that are our borders. They are breaking our graph into 4 regions. Region 1, Region 2, Region 3, and Region 4. So, which of those 4 regions is both to the right of our black line and below our white line?
1.
So I'm going to shade that entire section. If that section crosses an axis or multiple axes, make sure you shade on both sides of the axes or axis. Okay, so see how we cross the x-axis? Don't just shade above the x-axis or below the x-axis. Shade that whole... Ignore the fact that there's axes, basically, when you're shading, unless you've used that as one of your lines. Because that's one of the places people make mistakes on this, is they'll go just until they see another line. And unless that's an important line for you, you don't worry about it. So 9. The first one is y is less than negative 1/3 x minus 1. So my slope, I already have this where y is by itself. So my slope is what's multiplied times my x. So negative 1/3. My b is a negative 1. And so I start with my b, and is that on the x-axis or y-axis?
The y.
The y. So I put a dot at negative 1 on y. And then I am going to have a solid line or a dashed line in this case. Dashed. If you have troubles drawing a dashed line, when I'm doing this on pencil and paper, what I will do is draw in a solid line and then go back and erase dashes. It just doesn't work for me very well up here because I'm embracing more than I'm mean to. And so my slope was negative 1/3. So I'm going to fall. Oh, I didn't do that right. I'll see, it goes negative 3. So I'm going to fall 1, run right 3. And then I'm going to go in here and draw a dashed line. And so with that line, my graph is in 2 regions. Am I shading above that line or below that line? Below, because it's less than. You don't have to do the arrows. The arrows help me find a method that works for you. And then we're going to take the other equation, or inequality, excuse me. And it is y is greater than or equal to 3x plus 1. So my m is what's multiplied times my x. So 3. But when I find my slope, I always want it as a fraction. So 3 is the same thing as what fraction? B is the same thing or is what number in this case? 1. So I'm going to come over here to my graph and I'm going to put a dot at 1. And then I am going to rise 3, right 1. Or fall 3, left 1. And if you haven't written down those rules for slope, and slope is one of those things that causes you problems, they're still written on my board. Just make sure you get them written down. And so, since this is greater, okay, I drew it as a dashed line. Is that correct?
No.
Why not? So, because it has that bar, I'm supposed to have a solid line. That was not a good solid line. There are no dashes because there's that bar underneath. Now, am I going to shade above this line or below the line? So greater is what my symbol is.
Above.
So we're going to shade above. And so we're looking for this section that is going to be above the white line but below the black line. It is 3.
Wait, above the what?
Above the white line. And so if you have trouble seeing when they're almost vertical lines like this, take and look at your y-axis. What numbers are above 1? These up here, right? So that means I'm shading this side of the line. Because that was always hard for me as a student doing the above and below until I focused in on the y-axis. And if that still is hard for you, take an ordered pair to the right of the line and to the left of the line. And one of them is going to be true. So let's take our last one. This one was in here because what's different about it?
It's like 2x.
It's 2x plus y is less than 3. And so our variables are on the same side. That does not work for graphing in the system that we're using with the y-intercept. And so we need our x moved to the other side. And if we move it over to the other side, it changes its sign. It becomes negative. Or I subtract 2x from both sides, whichever way you see it in your head. And so y is less than negative 2x plus 3. Now I have y isolated. That means y is by itself. We can identify our slope and our y-intercept. So our slope is at negative 2, but I need it as a fraction.
Over 1.
I need my y-intercept. 3. Is this line going to be solid or dashed? So I start with on my y-axis at 3, and then I fall to right 1. And I go ahead and just plot that all the way through my graph to help me draw my line because I don't have a ruler. Now, are we shading above or below?
Below.
The other one is 3x minus y is less than 2. So I need to get my y by itself. So I need to move the x to the other side. It's a positive x, so I need to subtract 3x from both sides. Or when it comes over, it's negative, whichever way you do it. You don't have to show that step unless you need it. The 2 was positive, so that's the reason I have a plus in front of my 2. The y is a minus y, so that becomes down as a negative y. Is y completely isolated from everything else? No, because there's still a sign to it. To get rid of that sign, this is where people make a lot of mistakes. We multiply everything by negative 1. So that means every sign changes, including your inequality symbol. And so when we rewrite this, y is greater than 3x minus 2. So my slope is positive 3 over 1, and my y-intercept is negative 2. Is this going to be a solid or dashed line? Dashed. And so I start at that negative 2, and then I rise 3, right 1, fall 3, left 1, and then draw in your dashed line. We have at the end, when we are looking at the final equation, y is greater than 3x minus 2, because we have it solved for y here, completely. Are we above the line or below the line?
Below.
Y is greater than. And so we have above. And so I'm going to break it into 4 regions. 1, 2, 3, and 4. Which region is above the white line and below the black line? 3. So I shade in that entire region. So when it is dashed lines, that means my solution cannot be on that dashed line. When it is a solid line, my solution can be one of the solutions on that solid line that's next to a shaded region. So this part of the line that's next to the orange is a possible solution.